I want to thank the Spanish Network of Safe and Sustainability Nanotechnologies for this opportunity. Today, the title of the talk is not the easy one. It's Nanoscopy, Nanoscience and Sustainability. Okay, now. Well, we will start with just a very introduction to nanoscopy and nanoscience. Well, it is not necessary to mention that we talk about nanoscience and nanotechnology when we have elements with at least in one dimension in the range of between 1 and 100 meters. And even we have some elements for biology that are in this range. We can also fabricate nanomaterials in this range. There are some with organic materials or inorganic or even with hybrid materials. It is important to know how to prepare these nanomaterials, but it's also we have to pay attention to how to characterize these materials. To characterize these materials, we need at least through microscopy or this kind of system that I call nanoscopy, that includes all the scanning techniques. Well, nanoscience and technology have special properties just due to the increase of the surface volume ratio. We have more and more atoms on the surface, and in addition, we have these special properties because the lengths are the length of our structure are close to the length of the important physical parameters. I will use the graphene as an example of what happens when we reduce the size or what kind of applications we can find. In the case of graphene, due to this very, very one-dimensional one-dimensionality, we found that we have special mechanical properties or even lubricanting, but also special thermal or electrical conductivity, and also some special properties about the permeability for special gas or for special materials. What about the applications? We can use this kind of material for energy, environment, sports, industry, defense, aerospace, electronics, communications. If we want to use from the point of view of the sustainability, we have to take care of how we manage all these materials. We have tried to follow this circular economy model, taking care of the kind of materials we will use, how to design not only the synthesis but also the production, the distribution, think about how these materials and these devices will work in terms of consumption, how reusable will be, how easy to prepare. We have to think also how to collect all these materials and devices, and the way we will eliminate this waste, and if it's possible, how to manage this waste to include again in the system. Well, then it is clear the relationship between nanoscience and nanoscopy in order to characterize these materials, and nanoscience and sustainability for the development of all these materials that can help to enhance the sustainability of our society. Then, what in this position we can include the women's visibility? Well, for that, let me explain a little bit the history of the nanoscience and nanotechnology, just focusing on some key persons in this topic. We have to start with Feynman, that predicts that in principle there are no physical reasons that avoid to manage the materials at the atomic scale. And he mentioned that that's a problem of how to manage or how we can develop the tools to manage these materials at the local scale. We have to mention also Taniguchi, that used for first time the word nanotechnology. But let me say that he didn't mention in the sense of we know now with all these special properties that have been appeared along the years. But in that case, more just the natural evolution from the microelectronics to the nanotechnology in a moment where we are just working with elements in the
A ver, Miguelito, a ver si me refieres.
We can mention also Drexler. Drexler was one of the enthusiastic supporters of this idea. He dreamed about just a collection of molecular devices, molecular motors, molecular gears, bombs that can be worked for us. His idea has something negative involved because some people was just frightened for this idea of being controlled by the machines, by the molecular machines. And this is something that could happen also now with the artificial intelligence. We have to mention also the researchers that discovered the fullerene and characterized the fullerene, and well, to mention that they received the Nobel Prize for this. Also, similar kind of materials based on carbon. We have to mention Gaiman and Sokolov that also received the Nobel Prize for the first time isolate the graphene, the single layer of carbon. But well, if it is important, all these examples of these people that have to achieve to control and to fabricate nice nanoparticles and nanostructures, it's also important to develop characterization methods. But if we will look now for important person in this topic, and we find, for instance, Mildred Westerhaus. He used Raman spectroscopy to characterize carbon-based materials, and her experiments was really important for further characterization of amazing things like fullerenes, carbon nanotubes, or graphene. And of course, we have to mention Vinith and Rones. Their contribution was especially important for the nanotechnology because in some way they promote the evolution and the spread of the nanotechnology. They also received the Nobel Prize in 1986. Let me go to the local information here. I think it's important to remember that the second microscopy developed at IBM appeared in the University Autónoma of Madrid just few years after the discovery of the SCM. This new microscope was installed in the group of Arturo Baró in the University Autónoma of Madrid in the lab that it is called. Well, 3 years later, Eiler finally achieved to make real the dream of Feynman of move atoms one by one. In his case, he just used xenon atoms to move these atoms on top of a microstructure at very low temperature, and for that he used the interaction between the tip of the SCM and the absorbed atoms. Well, we will come back again to the graphene example. Just remember that the SCM gives us more information, not only the topography information, but something related with the local density of space. Well, we'll see what happens if we have 2 layers of graphene. We can play with these 2 layers and change the angle between these 2 layers and see what's the effect in the local density. This is what paid attention of many groups in the last 15 years. Here you have some examples. Due to this different orientation of the different layers of graphene, it is possible to obtain what it is called a moire structure. That this is what you can see here, a superstructure imposed to the contrast related with the dominant solution. Well, in the slides you will see that some names appear in blue and some of them in red. This is just to remark the participation of men or women in this study. Well, I looked for the authors that have been published in this topic, just looking for SCM, graphene, and moire, and this is the list of the 15 authors that have more contributions to this topic. And well, as you can see here, we can find only few percentages of female researchers. Well, what happens if you just look for the publications with higher number of citations? And here again, well, this is that was really a hot topic, and you can see that it's possible to see articles with many citations. Some of them that belong to groups in Spain. That is a signal of how important is the Spanish community in Spain for microscopy. But we will left SCM and we will try to see what happens with people that work in atomic force microscopy. Well, of course, we need to mention the people that developed this system, the scanning the atomic force microscopy, Dennis Wade and Gerber. This contributes also to the development of the nanoscience and nanotechnology, even in my opinion, even more than the SCM, because we will use this system to characterize conductive and non-conductive materials. We can work in different environments, just on liquid, physiological conditions, to air conditions, or high vacuum or ultra high vacuum. And I will remark a couple of achievements. In my case, something really important for the future of this process. Well, in this example, they achieved to manipulate atoms for the first time at room temperature, in comparison with the previous example made by IBM using the SCM. In this case, they move thin atoms on top of a germanium surface, and again, I repeat, just at room temperature. This work was in collaboration with a Spanish group and a Spanish researcher, and the next example also belongs to the same group. And in this case, they achieved to determine the chemical composition of each atom of a surface. As you can see here, in some way they color the atoms regarding its composition. Well, and the idea is just they perform this kind of measurements that are called force resistance curves in such a way that we can obtain a fingerprint of each atom when we perform this kind of curve. Well, this is the history of the nanotechnology and the microscopy related with the scanning force microscopy. And clearly, we can see that it is quite difficult to find a woman that was named, that was a prestigious position in this topic. Just to have only male. Well, but this is something that was quite usual in the past. Here you have a picture of the first SCM Congress that was held here in Spain, and you can see that it is really hard to find a woman in this picture. I just make an estimation that we have around 3% of female scientists at the beginning of this technique. Well, something is changing. This other picture corresponds to one edition of this scanning tooth microscopy promoted by Arturo Baró. It is called Portas y Túneles, and this is the Spanish Congress. And 20 years after this, the previous image, the female participants are in the range of 33%. But the same happens in other topics. Well, this is an example of a list of very prestigious researchers. In this case, I use the data from INANI from Stanford University. Here, this is the list of the top 50 researchers in Spain. And again, the percentage of women is in the range of 8%. Well, we have not only the number of people or the balance, the gender balance is a problem, but also we have additional problems that could be worse and worse in the future. For instance, Longa Steenberg mentioned the unconscious gender bias in the Google algorithm. This is something that also could happen in the artificial intelligence, and in fact, there are a lot of people that are trying to determine how biased is this new technology. Well, just to summarize, we have a problem, a real problem of gender balance in science, in particular in nanoscience and in microscopy topic. This is important not only because that means that the young guys don't have some models to follow, but also it's a problem for the society. Science is using the talent of almost half of the potential future researchers, but also it's a problem for the women as a global entity, since really the careers related with the STEM give more probabilities to obtain higher salaries and best way of life. That means this is a problem for the women in general. And the point is, what can we do? We can look for new models, female models, to motivate the girls to take the STEM career. In the Quality Commission of the Institute of Materials Madrid, we have published some best practice guides just with some ideas, just to be aware of this problem and try to give some ideas of how to decrease or to solve or just to make less and less the discrimination between women. But the point is that even there are only few of them in the most prestigious positions, we have some well-known researchers. Here we have an example of Franklin, Fleming, and Eva Noales. In Spain, we have also women with very relevant positions, as Caterina Vizcari, she's the director of Alba Synchrotron. Maria Varela is the director of the Centro Nacional de Nanoscopy. Maria García Carajo is a well-known researcher in the topic of mapping and visualization of biomolecular interaction, and she received several grants, awards and prizes. But in some cases, we have some women that are not so well known. This is the case, for instance, of Carmen Ocal. Carmen was the first Spanish woman working on STM, both in theory and in experiments. Not only in Spain, probably she was the first in the world. She was also pioneer in the use of AFM in the characterization of organic and inorganic materials. Perhaps we need to remark the work of women like this. But it is not the unique one. We have many researchers in Spain that made really nice achievements and have a lot of offer to the society. Well, for that reason, in 2022, Pedro Serena, Angela Bonacera, and myself decided to open a video contest. It's a video contest for students, and the idea is that we elaborate a catalog of researchers, of female researchers, and we offer this catalog to the students. And the aim of this is that they present a short video. It's a video of 50 seconds, just 50 seconds, rated with one of these researchers. We made the first congress in 2023. At the beginning of this year, we launched the second one, and now we are preparing the third edition. Here I will show you some examples of the researchers that appear in this catalog. Lucia Valle, she is working in Alba Synchrotron. Pilar Aranda, working in our institute, the Institute of Material Science of Madrid. She is expert in the use of materials, very low price and very common materials like clay. And she can apply these materials for different applications, for instance, nanomedicine, the degradation of ibuprofen, or environment applications just to remove pesticides and pollutants, but also in energy, just to make more efficient the workforce applications. Well, Sonia Contreras is a researcher in the institute in the University of Oxford. Is an expert in AFM and also in the application of this technique to biology. Isabel Diaz is a researcher of the Institute of Catalysis and Petrochemistry. She is expert in microscopy, but she studied theories for many years. Several years ago, she realized that it would be interesting to use this material, this posed material, in a new technology to remove fluoride from water. She was really successful in this technology. She achieved to remove this fluoride, but it is really dangerous for the growth of the people since it affects the bones and the teeth. This technology is completely transferred to the company that it is just using in several countries in Africa. Neus Domingo, working also in AFM. Cristina Gómez Navarro, she is expert in AFM, but also in three-dimensional materials. Laura Ichua is a well-known researcher, mainly working in the development of a new sensor based on nanophotonics. She has many publications. She's co-founder of a couple of companies, and she received several prizes and awards. Marisol Martin, also expert in nanomaterials for energy. Walter Morales is perhaps one of the most important person in the topic of nanoparticles. He has been working with magnetic nanoparticles, synthesizing different kinds of nanoparticles with different shapes and different applications. The most important ones are related with the catalytic process, biomedicine applications, and also water treatment. Eva Nogales is expert also in microscopy and applied to biomaterials, and let me say that it's the first female researcher that is principal to be in a list for the Nobel Prize. And Marisa Vallet is also a well-known researcher in the topic of nanomaterials for medicine. She has also a member of the academy. She has a lot of contributions in this topic. And We can mention many others working in different institutes in different topics related with nanomaterials and nanotechnology. And all this collection of women is what we offer to the students to prepare the videos. Well, just mentioned that we have tried to collect profiles from different regions, different places of the country, and different areas. They are expert in different areas, although most of them are in biology or physics. This is the area of the video that's achieved to the final phase. We have received videos from students from different places. Well, a huge of them are from Madrid. Let me say that in the last edition, it was allowed to use co-official languages. But even though we have still problems to reach the students from regions like Canarias, Cantabria, La Rioja, Navarra, there have also problems with the participation of the students from Andalusia, Castilla y León, or Catalonia. Because the amount of videos that we received, in the first edition, more than 200, finally only was accepted 150, and in the last edition we have accepted more than 200. Well, this is what happens, but this is the distribution, the gender distribution about the students that participate. Most of them are women. These are the boys that participate in the well, just to explain the evaluation process, we evaluate in a first step, thanks to the participation of more than 100 scientists that was divided in different panels, and thanks to this selection, we have 10 finalists. These 10 videos have been finally evaluated by a nice professional jury composed by people from communication and science. And also in the last edition, we also issued the vote of the public. Well, if you are interested, you can look in the webpage of our institute for the winners, or in fact for all the finalists of the two editions. In the first edition, the video was about Sonia Contera, and in the last one was about Isabel Diaz. Now we are preparing the next edition, the edition of 35. We are open to receive the profile of new researchers. You can collaborate in this catalog, just sending us your information, or just sending this information to some colleagues that can be interested or being included in this catalog. You can also distribute information, and you can participate also in the evaluation panel. But this is really helpful for us. Well, this is all I want to say today. This is not the typical talk that we used to do this, but well, I think that it's a compromise with the women, with the equality. And let me say that this activity is also included in the activities of this network. Well, thank you to all of you for your attention. Curiosity.
Agustina, thanks. One question, how do you think we can improve the contribution of women? Because still today we are here a few, I mean, we are not too many people, and I see almost all are women in a network, which usually I am in the meetings of the network, we have just Jasmine and Margarita, and then there are Pilar, the other Pilar from Zaragoza, and me. And all the other are men, but today they are not men. So what we can put, or how we can do something to push in these things to balance. Thank you.
First of all, clearly you have to learn how to achieve the attention of the men, because I mean, in principle, this is not, as I mentioned, it's not only a problem for the women because we are less visible, but it's a problem of the society. I mean, we lose the talent of all these girls that can be successful researchers in the future, and we also make less equitative the life of the women, because I mean, if we don't have models, we will not promote the girls to study STEM careers. That will be, I mean, statistically, their life will be less successful than the people that work in this area. I mean, the question is completely timely, but I mean, I don't have the answer, because clearly today we fail. I mean, to ask to take the attention of the men. I don't know if some of you in the audience can say something, can comment something in the topic. In any case, perhaps Pilar, in your next meeting, the next meeting of the network, perhaps this is something that you have to mention.
Yeah, I will note this. I am very surprised that no men are coming, and then it looked like it's for me. It's like they were thinking, but this is not important. I don't know if we have to push more, or I don't know what we can do to change this. But actually, it's like for looks like this is not important, or the important thing is the one I am doing, something like this. And maybe we are not the same, the women, when we look at these things. And it happened in these things, and it may happen also in the way of science also. We are less visible, like you say, and it is important to keep pushing. That there is another way to make science, or to look at how to express the things, which, but it's hard. In a world that every day looks more like we are once again others, it's complicated. Hope we can think in strategies that could work for this.
Yeah, because in principle, I mean, the call was thought not only just not completely focused on the equality. I mean, was just at least I try to explain, to put some numbers. I mean, just putting the real numbers there, and just try to think about what happens. Imagine if the title was just something like positive action against against the gender imbalance.
Hello, Agustina. Can you hear me?
Hi. Yes.
I'm Yasmin. Thank you so much for your seminar. I wasn't able to introduce you because my browser blocked my mic, so I had to leave the session and then open it through another browser. So I apologize for that. So yeah, I wanted to thank you for all the insightful information you shared with us, and like how, like the invisibility of women in the world of nano, but also the efforts that we are doing together to make the gender balance in this area. And from also what Pilar discussed, when you showed the numbers of the participants in the contest, the video contest, I was happy to see that even though female participation was the majority, I was happy to see that at least there was quite a big bunch of male participation, because it's important to educate both genders on the visibility of women in research. So therefore, I was also shocked that when you mentioned that Google search, like the algorithm, is not pushing, or hiding female publication. And it's true that there is a tendency between female researchers to cite between each other, because otherwise there is no other way to make like their publication to be seen or to be like accountable. So I don't know if you could share with us on what to do, or some techniques, or what we can do to change that, and to make it more visible, or at least to somehow not having an engine that is hiding.
Well, as I mentioned, we have published this guide with some sample ideas of how to try to make more visible, or just to realize the problems of this discrimination. In the case of the publication, it's difficult. I can think about, for instance, when you think about who must be in a publication, perhaps there are some people that will invite some men because they are well known, and this is nice for the publication. And perhaps it's again the problem of the women, since we have less visibility. Sometimes that could happen, but we are not included in the paper. But for me, what it is more easy to do, or to be aware of this, is the participation in the Congress. I mean, if you receive an information about the celebration of a Congress, and you see that the list of the speakers, all of them are men, or 90% are men, I mean, for me, we must reject to participate in this Congress. It's just something that we must have a red line. I mean, we cannot do it. The rest of things, I mean, it's something that we need time, and I don't know if we have to push in a stronger way.
Okay, thank you. Yeah, it's true that we have to make accountable for this type of events, congresses, or like even this network. If something is not aligned with gender balance, then we should speak up or be against it.
Okay. I don't know if someone else wants to comment something. If not, perhaps we have to close the session. Okay, Jasmine?
Yeah, for me, I just wanted to add for everyone here present that the seminar, Sustainable Nano Seminars, are monthly seminars, so check the website to see the next one. We try our best to have equal representation, both male and female, between the speakers of our seminar. So I hope you can follow the other ones. The next one will be on December, and it will be by Esther Palmero from IMDEA Nanoscience about advanced fabrication of permanent magnets. So we hope to see you there as well.
Okay.
Thank you, Agustina.
Thank you. Bye.